Tutorial number 6. In today's tutorial, we're going to begin actually creating an end-to-end machine learning project. Now, up to this point, over the course of tutorials 1 through 5, we were going over some more theoretical concepts. We went over different types of learning systems: supervised, unsupervised, semi-supervised, reinforcement learning. We went over different ways, different learning systems as it relates to collection of data. For example, batch learning versus online learning. We went through instance-based versus model-based learning and how that can affect our outputs and how generalization worked. We talked about overfitting, underfitting data, poor quality data, insufficient data. And so we talked about many of those factors throughout the course of tutorials 1 through 5. In our last tutorial, we covered hyperparameters versus parameters, testing and validation, all of those different things. That was all theoretical concepts, and that was mainly what we've been covering up to this point. Over the course of the next 4 to 5 tutorials, what we're going to be doing is going to actually be building our own machine learning project. And so we're actually going to be getting into doing actual coding. Okay, so up to this point, we haven't actually done any coding at all, and so we're going to actually be doing coding. And so what we're going to be using is we're going to be using Python, obviously. And so you should have a good knowledge of Python in order to continue in this tutorial. If you don't, go over and learn Python. There's many online tutorials that you can use in order to learn Python. Many online tutorials, and you can learn Python fairly quick. Also, you should also have. You don't have to technically, but it would be a good idea as well that you have a Jupyter notebook installed on your system, and so you can access that locally on your device, and that's connected obviously to the different file directories that you have on your file manager or your file explorer. And so that's what you should have as well, your Jupyter notebook. Now, also, we will be using NumPy. We'll be using Pandas in this particular chapter. We might be getting into Matplotlib a little bit. You do not need to know those libraries necessarily. And the reason is because the information that you're going to be, the functionalities, the methods that you're going to be using in each of these modules is information that you can learn as you go on the fly, basically, right? So you can learn that information as you go on. You don't need to spend time learning that information necessarily. We'll be covering that information. I'll be explaining, by the way, that information to you line by line. And basically all the coding in this chapter, I will be explaining line by line, unless it's not like basic things like how do you define a function in Python. I would expect that you know how to write a function in Python, how to loop through lists and dictionaries and all those different types of things. You should be able to do that. So anything that's like above that, I'll obviously explain it to you. Okay, so let's go ahead and start off with our end-to-end machine learning project. So what are the different steps that we're going to be going through? Well, the 7 steps we're going to be going through. The first step is getting the data. We obviously need to get some training data. Now, our training data is going to be a CSV file. So we're going to be using a CSV file for our data. CSV stands for comma separated values. And basically, it's a form of getting data where basically each row represents one data entry. So each row in our file will represent one data entry. Now, each of the different features will be separated by commas, hence the word comma separated value, CSV. And the first column will be the first row in our CSV file will be each of the column names, and they'll be separated by commas. And you'll understand this more when I'll actually show it to you, and you'll understand it very easily. But that's the type of data we're going to be using, a CSV file. There's different ways of data collection. There's JSON, there's XML, there's different ways of collecting data. We're going to be using a CSV file. XML was a little bit more popular before, although now JSON is very popular as well. We're going to also discover and visualize the data. So discovering and visualizing the data, that's what we're going to cover in the next tutorial, actually. In this tutorial, we're focused on getting the data. That's our focus right now. And also getting some basic things set up in today's tutorial. But we're going to discover and visualize the data in terms of how can we graph the data? How can we notice correlation and trends in the data and things like that? The next steps we will get into when we get into them in the following tutorials. We might get into the third step actually in the next tutorial. But in today's tutorial, we're focused on kind of getting everything set up and kind of laying the groundwork for this project as well as getting the data. All right, so that's what we're going to be doing in today's video. Now, there's different ways of getting training data. Now, normally we store data not in a CSV file. We'll store it in some sort of database. You might store it in a MySQL database or different databases that you prefer. But in our case, we're going to be using a CSV file, and the reason is because it's very easy to get a CSV file loaded up, and also we don't want to deal with writing MySQL, with writing SQL queries or anything like that right now. We're focused primarily on the machine learning aspect, and using a CSV file will allow us to directly go into that, and we don't have to assume that you know information that you don't know. it's going to be very basic if we're just using a CSV file. We're just going to have to import basic Python libraries for that. All right. So that's what we're going to be using, a CSV based data set. So let's talk about what we're actually doing for this particular project. So this particular project, we're going to be using training data that comes from the 1990 California Census data. Now, the California Census data provides a lot of information in that particular Git repository that we're going to be going to. It provides a lot of data. And so it provides, for example, one of the data it provides is the median income in that particular area. It provides the population. It provides the location. It provides different factors, different features that we can use in order to make predictions. Now, what's our goal in our prediction? Well, our goal in our prediction is to identify the median housing price per district. Median housing price per district. And so using the data that we are given in that CSV file is also going to give us the longitude and the latitude, the coordinates there for each particular row there in the CSV file. It's also going to give that information. Using that data, our goal is to predict the median house price per district. So that's a very simple goal that we're going to be using. Now, why exactly would we be asked to do this? Well, we're going to be asked to do this to identify promising areas for investment. So maybe a business wants to invest in a particular area where the house price is maybe higher, right? Because then they can get a greater return on investment. And so because of that, that's our business goal. And this goes into the idea of machine learning pipelines. Okay, machine learning pipelines. So machine learning pipelines is a sequence of data processing components. Each component will run asynchronously. So let's go back to the previous slide and take a look at this. You see your upstream components. Okay, upstream components are going to determine our district pricing. Okay, our district pricing. This is very important because the goal of our model is to determine the median household price per district. But once we get that information, we might bring in other predictors into our model in order to do investment analysis. Once we get our investment analysis, then we can determine which investments can go into different districts, different communities, right? And so that this is the basic idea. We're going to use district data. The district data would be, for example, population and median income. Using that district data, we're going to determine district prices, right? District prices, so the median household price per district. Once we have that district price, then we're going to input other signals. So for example, we not only need to consider district price, we would also need to consider other factors as well, such as, for example, maybe house prices were high up to this point in a particular area, but maybe now they're going to slow down because there was, let's say, flooding in a particular area or something like that. So we might input other signals, and then we'll do some investment analysis. And then once we're done all of that, then we'll actually say where we should invest. And so the portion that we're going to begin is the district pricing. That's our focus right now. And then we might also input other signals as well once we get a district price in order to determine where we should invest. That's the idea there of a machine learning pipeline. Now, the pipeline may continue to run even if one component fails. And the reason for that is because it might just use old data that's already existing there. Now, this is very true also in online learning, where if the data isn't being updated, the pipeline can still run, but if it's using old data, then the quality of the machine learning algorithm cannot be as well. So, for example, let's say you had to create a weather predicting model, and you had to give in different features, features or predictors, such as, for example, what's the current temperature, what's the current wind speed, what's the current humidity, different factors like that. And let's say, for example, for like 2 days in a row, you didn't update that data. Well, is your model still going to be able to predict? Yes, of course. But will it be as accurate if you leave it for 5 days, 6 days? No, obviously not. And so it is going to run, even if one component fails, the pipeline may continue to run, but we obviously want it to work there. And obviously this is going to work asynchronously because each component here has to finish in order for the next component to continue forward. All right, so that's the idea of machine learning pipelines. Now, some key questions about our model that we're going to be creating. Now that you know a little bit about it, is this supervised, unsupervised, semi-supervised, or reinforcement learning? Well, in this case, we are going to be using supervised data. Since our data will be labeled, we'll know what the price is for each area. Does the data system use batch learning or online learning? Well, obviously, we're going to be using batch learning. And the reason for that is because our data will be static data. It's not going to be data that can be updated. Now, it is good to learn online learning as well, but for this project, we're going to be using batch learning, okay? How many features are going to be used for the prediction? Well, many features, obviously. We're going to use features such as, for example, what's the population in that area? What's the median income maybe in that area? What's the median age in that area, right? If people are very old and they already own homes, then that's a factor to consider, right? How many predictions are generated? Well, predictions, in this case, we're generating one prediction. Our goal prediction is determine the district house price the median household price per district, right? That's our prediction that we're generating. One prediction with many features going in. Okay, and obviously we can use. So now that you're on, hopefully, our Jupyter notebook, go ahead and create your own file under a folder. So create like a machine learning tutorial folder or something like that, and go ahead and create a file, name it like data retrieval or something like that. And what we're going to do in this file is we're going to simply retrieve the data in order for us to view and kind of just analyze the data. Now, in order for us to do this, what we want to do is we want to go to the GitHub repo, and what we're going to go ahead and do is we're going to download it. Okay, so go to the GitHub repo that I have in the link right over here. It's in the link in the description below. When you go to this particular link, it should automatically download it for you. So it'll download that and it'll save it in your downloads folder. From there, what you're going to go ahead and do is copy that file and put it and create a folder called datasets. And inside that folder called datasets, put that file housing.csv. So it'll probably be in a zip folder. It will be in a zip folder. Go inside and get the housing.csv file from that zip folder, and then you're going to go ahead and save it there. Okay, so make sure you go ahead and do that. Just get that zip file, get the housing.csv file, create a datasets folder, save it there, and you'll be good. Okay, so that's what we're going to have there. Let's go ahead and view this housing.csv file that we're going to be using as our training data. Now, remember what we talked about, training data has to be very big, right? We talked about one of the problems that we have in machine learning is insufficient training data. Well, in this case, we don't have enough. Technically, we only have 20,640 entries. And that might seem like a lot, but remember, in machine learning, typically speaking, we deal with hundreds of thousands or millions potentially of training sets. But this is a pretty big data set, nevertheless, just in terms of a human perspective, right? More than 20,000 instances of the data. And so, again, our job here is to figure out, again, the median house price per district. That is our goal. And remember, what the data that we're working with, we talked about this in the PDF file, is supervised data. So supervised data, what is supervised data? Supervised data is data in which the training instances have are labeled, right? Meaning that the output is already given, right? And so we just need to use that as a training data. And so in this case, it is labeled since they do give us the median house value for those particular latitude and longitudes. But remember, we're doing this for particular new instances. We're asking new instances, the new districts, things like that. But we are also given several predictors. We're given the longitude, the latitude, the housing median age, right? Total rooms, total bedrooms, population, households, median income, ocean proximity, all those different factors that are very important. And so obviously, as you can see here, this is very relevant. And let me just go ahead and see if I can zoom out a little bit. Um, yeah, so you see here, just to put it all in one page, you see all these different factors, and you see here how it's labeled instances of data. Now, keep in mind here, since we're downloading this file, and this file is obviously immutable, it is mutable technically, but since you can add columns and things like that, this data is not going to be updated, right? We're not going to be regularly updating this data at regular intervals. As you can see here, this file was updated 9 years ago. And the reason why is because this is obviously representing data from the 1990s, right? So you need to keep that in mind. And so because of the fact that we're not updating this training data, this is going to be batch learning. We talked about that in the PD when we were talking about it just a few minutes ago. Okay, so it's batch learning as well. This is going to be univariate. We're going to be solving for a univariate solution. What does univariate mean? Univariate basically means is that we're going to have one thing that we're looking for, one factor that we're looking for. The one factor that we're looking for in this case is the median house price, and that is the factor that our machine learning model is going to predict. And we need to feed this training data to our machine learning model and create an algorithm in order to do that. So that's what we're going to be doing. So it's a univariate data. It does have multiple things going in, multiple predictors going in. And again, we talked about this a while ago. We're giving the longitude, the latitude, the house median age, total rooms, many different factors that are going into our model. Okay, so hopefully this little bit helped you to understand what our training data looks like. With that being said, let's go back to our data retrieval Jupyter notebook, and let's go ahead now. And first of all, start off by importing the pandas library, and you can also import OS as well. We might use that a little bit later. So the pandas library, if you don't have it installed yet, you want to make sure you go ahead and install it. And the reason why is because pandas for most machines is not already installed. So make sure you go ahead and install it. OS should probably already be installed on your device. Also, you need to obviously install Python. I assume that you already know Python. You have a lot of experience with Python. And you also need to install Jupyter Notebook if you haven't yet installed a Jupyter Notebook as well, and get that Jupyter Notebook running there on your command through your command prompt, your command line. So with that being said, now that you have the data stored, let's go ahead and kind of read this data using the pandas library. Okay, using the pandas library. Okay, so I'm going to say def read read underscore csv underscore file, and what we're going to pass inside is we're going to pass the path. Okay, we're going to pass the path as a string variable, and then what are we going to return? Well, we're going to return an object. Okay, we're going to return an object in this case. Okay, the reason why is we're going to return a data frame object that is going to go into the CSV file essentially. Okay, now what is our path going to be? Well, in this case, our path is going to be datasets slash housing.csv. Datasets slash housing.csv. Now, what's the functions that we're going to use in order to read this data? Well, the functions that we're going to use is the read underscore CSV function. So the read underscore CSV function. And so we're going to say return pd.read underscore CSV. And then I'm going to pass the path inside of that. Okay. So the path is going to go inside of that. And what this will basically return is it'll return a data frame object that will go through the individual rows and columns and display it to us. Okay. So this is just something very basic that we're doing here. Let's go ahead and run this. And what we see here is that when we run it, we get all the data here nicely displayed. Now it does skip here certain rows just because of the fact that, it's 20,640 rows with 10 columns. But you see here that it is outputting our data. And that's what I mainly wanted to do today. So our goal today was just to read the data a little bit and get into the data and understand what type of data we're working with. Also, you should be installing, if you don't have Jupyter Notebook installed, if you don't have Pandas installed, if you don't know Python, you need to go and learn Python, all those different things you want to do. But right now, you see all this data here using the Pandas library here, the Pandas library that's returning a data frame object. Okay, so that's everything we wanted to cover for today. Make sure